Most people see a plateau as failure, but biologically, it is evidence that your body has succeeded. When you first begin training, progress is rapid because your body is unfamiliar with the stress. Strength can increase by up to 20 to 40% in the first few months, largely due to neural adaptation rather than muscle growth. Over time, the same stimulus produces less disruption and the body stabilizes. This is called homeostasis, the internal balance your system constantly defends. The plateau is not resistance to progress. It is proof that your body has learned the task and reduced its cost. A well-known principle in exercise physiology explains this clearly. As stated in research from the National Strength and Conditioning Association, quote, adaptation occurs when the body is exposed to stress and responds by becoming more efficient at handling that stress, end quote. Efficiency is the key word. Your body is not trying to grow endlessly. It is trying to survive efficiently. Muscle strength and endurance are expensive. If the same workout no longer threatens your system, there is no reason to invest more energy into change. Imagine learning a language. At the beginning, every word is difficult. After repetition, it becomes automatic. Your brain stops working as hard. Training works the same way. What once forced adaptation becomes routine. This is why doing more of the same rarely works. It is like rereading the same chapter and expecting new knowledge. The insight is simple but powerful. A plateau is not a wall. It is a signal that your current stimulus is no longer strong enough to force adaptation. When you understand this, frustration turns into strategy. If this reframing helped you see your plateau differently, subscribe and like the video so you can keep building understanding instead of guessing. Progress in training does not slow randomly. It follows a predictable curve called diminishing returns. In the early phase of training, your body is highly responsive because almost any stimulus is new. Strength gains during the first year can reach around 40%, but after that, annual improvements often drop to 5% or less. This is not because effort decreases. It is because your system is already closer to its current potential under that specific stimulus. The mechanism is rooted in how adaptation layers over time. Early gains are dominated by neural efficiency. Your brain learns to recruit more motor units, coordinate muscles better, and reduce inhibitory signals. These changes happen quickly and do not require large structural changes. Later, progress depends more on actual muscle hypertrophy, which is slower and energetically costly. Building new tissue requires sustained protein synthesis, hormonal support, and recovery capacity. A position stand from the National Strength and Conditioning Association explains this pattern clearly. Quote, untrained individuals experience rapid improvements primarily from neural adaptations, whereas trained individuals rely increasingly on muscular adaptations, which occur at a slower rate, end quote. This shift is why progress feels like it disappears, when in reality it is simply slowing down to a biologically sustainable pace. Think of it like filling a glass with water. At first, it fills quickly because it is empty. As it approaches the top, each additional drop matters more, but changes less visibly. The effort stays the same, but the visible return shrinks. The key insight is that a plateau often reflects being further along the curve, not doing something wrong. Your expectations must evolve with your level. Early progress is fast and forgiving. Advanced progress is slow and precise. One of the most common hidden causes of a plateau is the absence of true progressive overload. Many people believe they are increasing intensity, but when examined closely, the stimulus has remained nearly identical for weeks or months. The body only adapts when it is forced beyond its current capacity. If the load, volume, or tension does not meaningfully increase, adaptation stops. The primary driver of muscle growth is mechanical tension. This means the muscle must experience a level of force that challenges its current structure. Research led by Brad Schoenfeld explains this clearly. Quote, mechanical tension is considered the primary driver of muscle hypertrophy, end quote. If you continue lifting the same weight for the same repetitions, the relative tension decreases as your body becomes more efficient. What once felt heavy becomes manageable, and the signal for growth fades. A practical example shows the problem. If you bench press 60 kilograms for 8 repetitions and repeat that exact set for 6 weeks, your body adapts quickly within the first sessions. After that, each workout reinforces efficiency rather than growth. Even if it still feels challenging, the biological signal is weaker because your system has already solved that demand. Studies suggest that increasing load by as little as 2 to 5% can be enough to reintroduce a growth stimulus, especially in trained individuals. Without this progression, muscle protein synthesis returns to baseline despite continued training. Think of it like a job. If your responsibilities never increase, your skills stabilize. Growth requires new demands. Training follows the same rule. The key insight is that effort alone is not enough. The body responds to progression, not repetition. If your numbers are not gradually increasing, your results will not either. Many plateaus are not caused by training errors, but by recovery limitations. You can apply the perfect stimulus, but if the body cannot repair and adapt, progress stalls. Muscle growth does not occur during the workout. It occurs after, during recovery, when muscle protein synthesis rebuilds tissue stronger than before. If recovery is incomplete, the system remains in a fatigued state and cannot move forward. Sleep is one of the most powerful recovery regulators. Research published in Sleep Science shows that restricting sleep to 5 hours per night can reduce muscle protein synthesis by around 18% and increase muscle breakdown. One study reported, quote, sleep restriction reduced anabolic signaling and increased markers of muscle degradation, end quote. This means even if training is optimal, forced sleep shifts the body toward loss rather than growth. Fatigue also accumulates across sessions. Each workout creates stress not only in muscle, but in the nervous system. Without sufficient recovery time, performance decreases subtly. You may still complete workouts, but with lower quality output. Over time, this creates a plateau because the stimulus is no longer strong enough to drive adaptation. Imagine trying to build a house while the workers are constantly tired. The materials are there, the plan is correct, but progress slows because execution is compromised. Recovery is the workforce behind your training. The key insight is that more training is not always the solution. Sometimes the fastest way forward is to improve sleep, reduce accumulated fatigue, and allow the body to actually use the stimulus you already provide. If this changed how you see recovery as a limiting factor, subscribe and like the video so you continue learning how to train with precision instead of just effort. A plateau often reflects a mismatch between your training demands and your energy intake. The body requires sufficient fuel not only to perform workouts, but to support adaptation afterward. If calories are too low, the system prioritizes survival over growth. If calories are too high, fat gain can mask progress and reduce metabolic efficiency. Both extremes can stall visible results. Muscle growth is an energetically expensive process. It requires amino acids, hormonal support, and a surplus of energy. Research in sports nutrition consistently shows that gaining muscle in a significant calorie deficit is limited, especially in trained individuals. One review notes, quote, energy restriction impairs muscle protein synthesis and reduces the potential for hypertrophy, end quote. In practical terms, if you are under-eating, your body lacks the resources to build new tissue, even if your training is effective. On the other side, excessive caloric intake can also create a plateau in a different way. When body fat increases rapidly, insulin sensitivity can decline and training quality may drop. Strength might still increase, but the ratio of muscle to fat gain becomes inefficient, making progress appear stagnant. A useful reference point is that a moderate surplus of around 250 to 500 calories per day tends to support muscle growth without excessive fat accumulation, while a deficit of similar size supports fat loss but may limit strength progression. The direction must match your goal. Think of your body like a construction project. Training provides the blueprint and stimulus. Nutrition provides the materials. Without enough materials, nothing gets built. With too many disorganized materials, the structure becomes inefficient. The key insight is that nutrition is not separate from training. It directly controls whether adaptation can occur. A plateau may simply be your body telling you the energy equation is misaligned. Another common driver of plateaus is program redundancy. When the same exercises, same angles, and same repetition patterns are repeated for long periods, the body becomes highly efficient at those exact movements. Efficiency reduces the stimulus for further adaptation. The muscles are no longer challenged in new ways, and growth signals decline. Variation does not mean randomness. It means introducing controlled changes that create new mechanical and metabolic demands. Research in resistance training shows that altering variables such as exercise selection, grip, tempo, or range of motion can increase muscle activation and prolong hypertrophy. A review in Sports Science states, quote, variation in training stimuli can enhance muscular adaptations by targeting fibers and motor patterns not fully recruited by repetitive loading, end quote. For example, performing the same flat bench press every session primarily stresses the same motor pattern and muscle fibers. Over time, your nervous system becomes highly efficient at that pattern. By introducing incline pressing, dumbbells, or slower tempos, you shift the stress distribution and create a new adaptation signal. This is similar to learning a skill in different environments. If you only practice in one context, your performance becomes specific but limited. Changing conditions forces deeper learning and broader capability. However, excessive variation can also be counterproductive. The goal is not to confuse the body, but to strategically expose it to slightly different challenges while still allowing progression. Small changes, applied at the right time, can restart progress without losing accumulated skill. The key insight is that the body adapts specifically to what it repeatedly experiences. If nothing changes, nothing new is required. Strategic variation reintroduces demand and breaks the plateau. Not all plateaus are physical. Some originate in the brain. As training experience increases, psychological fatigue begins to influence performance in subtle ways. You may believe you are training at maximum effort, but your perception of effort can drift away from actual output. This creates a hidden ceiling where intensity is lower than required for continued adaptation. This is explained through the concept of central fatigue and perceived exertion. The brain regulates effort to protect the body from excessive strain. Over time, especially with accumulated fatigue or stress, the brain may reduce motor unit recruitment before true muscular failure is reached. A study in sports psychology noted, quote, perception of effort is a key regulator of exercise performance and can limit output independently of physiological capacity, end quote. In practical terms, this means you might stop a set when it feels difficult, even though the muscle could perform more repetitions. Research on resistance training shows that training closer to true failure, often within 1 to 2 repetitions, produces significantly greater hypertrophy compared to stopping far earlier. The difference in stimulus is not always visible, but it is biologically meaningful. Imagine a built-in safety system that activates too early. It prevents you from accessing your full capacity. Over time, this becomes a habit. The plateau is not due to lack of ability, but due to conservative execution. The key insight is that effort must be measured, not assumed. Using tools like repetition in reserve or tracking performance can help recalibrate intensity. Sometimes progress returns not by changing the program, but by changing how hard you truly push within it. The final piece that resolves many plateaus is understanding when to reduce effort, not increase it. This seems counterintuitive, but continuous high-intensity training accumulates fatigue faster than the body can dissipate it. Over time, this masks fitness gains. The concept that explains this is supercompensation. Performance improves only after fatigue is allowed to drop. Periodization and deloading are structured ways to manage this balance. A deload is a planned reduction in training volume or intensity, often by 30 to 50% for about 1 week. Research in strength training shows that short periods of reduced load can restore performance and increase subsequent strength output. One study observed performance rebounds of around 5 to 10% after a taper or deload phase. A review on periodization states, quote, planned reductions in training stress enhance recovery and allow physiological adaptations to manifest, end quote. Think of fatigue like a fog covering your true ability. Training builds fitness, but also builds fatigue at the same time. If you never reduce the fog, you never see the progress clearly. A deload clears that fog, revealing the adaptation that was already developing beneath the surface. This is similar to charging a battery. Constant use without recharge leads to shutdown. Strategic rest restores full capacity and allows higher output in the next cycle. The key insight is that progress is not linear. It is cyclical. Stress followed by recovery creates growth. Without the recovery phase, the cycle is incomplete and the plateau persists. If this helped you understand how to break through plateaus with strategy instead of more effort, subscribe and like the video so you continue building knowledge that compounds over time.